Hello, everybody. We're here in front of a Haas CNC lathe. The model number of this lathe is the OL1, so it's the Haas OL1. OL stands for office lathe. It's a pretty neat little lathe because it runs on single phase power and can fit through a 36-inch wide door. All right, so it could be moved into areas that are, unindustrialized, which is pretty good because this little machine would be great for doing dental screws and stuff like that, which is an industry for CNC. Okay, why we're in front of this machine? This is the machine that you'll be making the piston for the air engine on. All right. The only thing you need to do on this machine is to get the familiar on how to turn it on, home it, put your stock in it, and get into a mode that allows you to operate, which is called memory mode, all right, to operate the machine. Okay? That's the extent that we're going to do. Now, while you're here, we'll discuss some things about this machine. All right, but let me grab a blank. This part, we discuss how to make the piston in an economical fashion on this for this part. As you can see here, this is brass, all right, and it has two journal ends on either end of it. All right, so we've come up with the idea here to minimize scrap and maximize the use of the stock by making a piston on either end of this part. So two pistons can be made out of this blank. All right, the blank is what goes to the machine. Also, if you look at your print set, you'll notice that the piston actually requires two different style machines to make it. All right, it's the only part in this series that we need to use a mill and a lathe. A mill. Here, let's move over to this camera here, Brian. Can you capture this? All right. You can see a little bit better over here. You can see that the flats on here are done by a mill. Then we got to drill through those flats with a drill bit. All right. And we drill straight down, which is the connection point for the crankshaft. All right, so here's how we do it. Here at the controller, all right, we have the power on button. You hit power on, the machine will boot up. After the machine boots up, you hit the reset button and the power up restart. Okay, the machine will home. It's a very quick routine. Then, on the side of the controller here, there's a little black button. That turns on the light so you can see inside. All right? Then, once the machine is booted up, home, you could run the part. Slide the door open. Grab the chuck key. Loosen up the chuck. You put the stock in. Now we already made a piston. The student has already been in. All right. So I am going to take this stock and I'm going to flip it around to do the other side. Use up the other side. Okay. You place the stock in the 3-drill chuck, very short, and you lock down the chuck just for safety. Machine is not going to cut when you hit the first cycle start. All right. I've used the machine's tool to come on out and set the length. Okay. So we've been talking about setting zeros over there on the Haas TL1 when you made or will make the crankshaft. We've used operator zeros and we talked about fixture offsets. Well, we have a fixture offset here. When I hit cycle start, okay, but let me back up a little bit. After the machine has been turned on, reset has been pressed, power up restart has been pressed to home the machine. We put the machine in memory mode. Okay? Memory mode will activate the program that you see here on the screen. Now there's only one program in this machine. I keep only one program in this machine to make sure no mistakes are made. Okay? All right, you hit cycle start once. Oh, the machine shut off on us. So let me do the power up restart. Okay? The power up restart, I had to do it again. Took such a long time getting started on this. All right, back to memory mode, cycle start. You'll see the tool comes out and stops. All right? We open the door, reach back into the chuck, and we pull the stock out to the tool. All right, you can see how I pulled the stock out, so it hits the tool, the end of the stock, not the flat, but the end of the stock. Shut the door. We hit cycle start for a second and final time, and your part will be made. Meanwhile, while the part's being made, let's try to zoom in here and actually watch that program as the machine is executed. Okay, might be hard to get. Maybe white balance will get it. Yeah, looking good. Yeah. You can see the program being run there. All the G01s and G00s. G01 is linear interpolation. G00 is rapid motion. The X's and the Z's are positional data. They are ordered pairs. Ordered pairs of positions in space in a rectangular Cartesian coordinate system. We're in a lathe, so we're in the XZ plane. That is G18, the XZ plane. All right. Every motion here has been linear so far. There's a G03. That's circular interpolation that just rolled by. Okay. The machine is using I and K to define arc center. R is also an option on a lot of machines. Okay. Some of the other things on the screen over here on this side, this is our offset data. Right? Every tool needs an offset. CNC is just like playing dot to dot. You know, everybody remembers your coloring books when you were younger. You can only program one dot about another dot, so each tool has to be shown offset to make those dots the same. Okay? Not as easy. Of course, it's a little more complicated and technical, but this first time we're here, the full CNC machine running CNC, don't want to overload. All right, you'll notice that as soon as this tool is done, you're going to see an automated cutoff tool. You did a manual starting off of your crank disc in the Haas TL1, and now you're going to get to see how it is done automatically within a program. This is a This is gang style tooling. Notice there is no turret on this machine. These tools are set into a gang orientation. Gang style tooling is very common on Swiss screw machines. All right, so with that, the piston is made. All right, y'all, it is required to file or sand this little tip off. All right, when you're done, I suggest using a well, any means. I mean, personally, I would use the belt sander, but the belt sander will make a very quick job of that. You don't want to press too hard, or you can file it off. Okay, if the first piston doesn't fit, which it really should, all right, we might have to do some offset changing. Okay, but if everybody was using the same reamer that we do have out for you, then we should be in pretty good shape that all the cylinders are actually being made the same size. Okay, see you soon.